Hello, Applied Physics. Sheet 9. Let's do this. This is what I'm going to do. I'm going to jump to the cart ones. Okay, it's homework 9. Jump to the cart ones. The following diagrams show vector forces acting on a wheeled cart. Show the final resting location of the cart by adding the vectors head to tail. I'll do a few of these. I can start with any one of these. Let me start with, I'll start with this one, and I'll add this one and this one to it. Here we go. So what I want to do is you want to get the scale as correct as you can. So the length for this one, I will do like this. I'll do like this. Okay, you want to do this with a pencil? With a pencil. That's the length for that. And then I want to add it to here, and I want to get the direction right. So this is pretty flat horizontal. So I definitely am going to do it like that. I'm going to do it like this. Okay, that's the distance, and then I can use a ruler to be as straight as I can. I have a little trouble because the camera's in the way. So this is that one. Add this to it. Let's get the length on that one. Right there. And then I'll go that direction right there with it. And I'm actually going to use my paper as my straight edge here. Right to there. Okay, so that's force 1, force 2, force 3. I'm just giving them any random numbers. That's where the resultant would be a line that goes this way. Which, if that would apply to the cart would end up with the center right there, center of the cart. I'm going to draw in my cart. And that's where the cart's resting position would be. The sum of those 3 vector forces right there. 8. Let's do 8. Here we go. Get a nice new piece of scrap paper. And perhaps I'll start with, I don't know, I'll start with this one. I'll start with 1, and then I'll do this one next. Doesn't matter. 3, and then 4. So that's 1. I'm going to add, 2 to it. So now 2 is this length here to here, and it's going in that direction. So I'll do this. And make sure the arrow is correct. That's 2. And then 3 goes in this direction. It's kind of weird when it goes back on the cart itself. 3 goes here, 3 is like that, and then it goes to there, which is kind of weird because it's kind of in the way. Okay, I'm right there. Okay, that's 3. Then I'm going to add 4 to it, and 4 is this long in this direction. 4 is this long in this direction from there. So it goes like this. Actually, I don't like that. Needs to be sort of more horizontal, or kind of due east in this case. If you want to pretend there's compass directions on there, like that. Okay, and that's where my final resultant vector would be here to there. But overall, that's what the sum of them all are. This will be the center of the cart, so I'll draw my cart. That'll be the center. Draw my cart in there. Cart. Okay. 9. Let's I'll start with this one, just because I will. I'll do this one, and then this one, and then this one. So I'll do 1, 2, and then 3. Again, the order you do them doesn't matter. You still will get the same exact answer. So, new piece of scrap paper. So I will go like this, and I'll mark. That's the length from the center to there. Keep that nice and like parallel to the original line. Make it look like this. Go like that. Okay, that's the end of 2, and then 3 will bring me back this way, which again is also kind of weird, but very realistic that this happens. There to there. That's 3. I'm eyeing up the sort of location. Right there, that's the resting point. The final resultant vector is right here. But the center of the cart, I draw my cart kind of. That would be the cart. So large forces, but they kind of cancel each other out a bit, so the cart does not move that far. Okay, let's see, do the cart ones. There's 3 more on the back. Do those. Okay. I will do some of these on the front, just to show these. Maybe I'll do 2 of these. I do like, let me see, I did an example on here. 1, And I did it like this: 1, 2, and then 3. So I traced them over here. 1, and then I added 2, and I added 3. The resultant force again from the starting point to here. Okay. So let's retrace them. So I'm gonna do. I don't care. I'll just do 1, 2, 3, 4. Let's add them together. So 1, and the directions are a little harder to get here. This is 1. It's a length. So I'm gonna just do it like this, and I'm transferring over to there. 1 is done. Then I'll do 2. 2 is going to be this here. How's my recording coming? Okay, just checking. That's 2, and it's in that general direction. So I'm eyeing up the direction as best I can. You can probably do a better job than I am, because you can get your head right over the paper, and you should not be in as big of a rush as I am. I don't want this video to be too long. That's 2. Then I have to add 3, which is that little bit right there. In that general direction, 3 is kind of about that direction there. That's 3, and then 4 is there and there in that general direction right there. Okay, like about that. Okay. So my starting point, this is where kids get confused. I started there, I ended there. I'm going to draw my resultant vector. I'm going to use a ruler. And overall, these 3 forces, it's a shorter force, and it's going in that direction. Watch this. So now my arrows are a little different. I'm not adding the arrows to the... I'm going like this. My arrows match up at the very end. Have to have the arrow in there. Has to be right. That's the resultant force. Okay. And that would be the magnitude, the length of it, and in that general direction. Okay. And then let's do 2. And again, the order I go in does not matter. Let's do, I don't care, 1, 2, 3, 4. We'll do it in that order. And I'm going to do it right over here. Let's do that. Here's some scraps. So 1, it's right here. Sharp pencil is your friend here. 1 goes like this in that direction. So I'll do this. Here we go. So that is 1. 2 is longer. 2 goes like this from there to there, and in that general sort of, if I go like this, I could eye them up a little bit better. Ooh, maybe more like, this is a little hard. Let me see. More like that, maybe. Okay, this is the tail. That's the head, that's 2. Then I gotta add 3, and then 4. So 3 is this way. It's gonna kind of get into my picture, my original diagrams a little bit, which is part of the world of vectors. This way I can eye up the direction of it pretty good. That's 3, and then 4, and this is my starting point. I got to remember that's my starting point right there. Maybe I shouldn't put a line there. That's my starting point. And then 4 is going to be like this, in that way, and I go right here to here, and it goes like this. That's 4, and now my resultant is from where I start to there, going that direction. This is where kids mess up, and you want to try not to be one of those people. You go like this. Now mine's still different. Start from my starting point to there is my resultant force, the overall force. If all 4 of these were acting on this, okay, label that and label it R. Okay, so from there to there, that's your resultant force. Doesn't matter the order you do it in. Just you want to make sure it's pretty much that about that length. Hard to tell in the video, obviously, but you can eye it up, go in that direction. This one should be that way, and use this as an example as well. And then there are these 4 on the back. And don't forget the back of these. So good luck with that. Enjoy it. Applied Physics. Homework 9, Vectors. enjoy.